So functions. I'm going to say the definition of a function is for every item in the domain, there's one and only one item in the range. And you have another one?
Yeah, so for every x, there's one and only one y.
For every x, there's one and only one y.
If you got two y's, you're in trouble.
I think in the past, we used the vertical line test. So if this is there's your, what we want to see if it's a function or not, we take a bunch of vertical lines and cut down through that. And if it hits the graph at only one spot, then it's a function.
That's a function.
Yeah, and if it hits it at let's say that's our graph. If the vertical line hits it in more than one spot, then it's not a function, right? All right, so domain is all of the values that x can have. So you want to get in your brain that domain are the x values of the function.
Right, and the range is just where all the y values that kind of make sense are all the put y values wherever.
Why? Because we said so. That's why. You're welcome.
Thanks.
All right, find the domain of each. So I'm going to look at this and I say, I want to figure out all the values of x. Now we're inside a square root. Remember, square root, you can't take the square root of a negative number without getting something imaginary. So this number inside here has to be bigger than or equal to 0. So x plus 3 has to be bigger than or equal to 0. Solve that, and x has to be bigger than or equal to negative 3. So that is the domain. X is bigger than or equal to negative 3. Sometimes we'll write that, if we look at that graphically, here's negative 3, and x has to be everything bigger than, ooh, that's closed hole, everything bigger than or equal to that. Or you'd say bracket negative 3 up to infinity. That's another way to say x is bigger than negative 3. It's from negative 3 up until you get to infinity.
Okay, in this one I'm going to break it up into two parts. So the top I'm going to look at, and we've got a similar rules we did up here.
Ooh, sorry about that.
That's all right. That we had up here is that x has to be greater than or equal to 0, right? Because it can't be negative. If I look at the bottom, the only problem I've got with the bottom is that if the bottom is 0, I'm in trouble. So if x minus 5 equals 0, then, or x minus 5 cannot equal 0, so x cannot equal positive 5. Okay, so if we think about the number line, first thing we've got anything greater than 0 is okay, and 0 is okay also, so we've got a closed hole. And that's what it looks like, except that we've got this problem at 5. So at 5, we've got an open hole. Is that
Pretty
much
like
it? Okay, let's write it a little bit more formally though. Let's say from 0 to 5, not including 5 though, we're okay. And then from 5 to positive infinity.
Yeah. If we look at that on the graph, we said, hey, from 0 till we get really, really close to 5, that's all fine. That's in the domain. All those numbers spit back a value in the original function. Keep going, I'm dying.
Okay. So once we get to 5, we're in trouble right at 5. But just a little bit after 5, if we keep going, all those numbers are also going to spit back a value, anything greater than 5. The only problem is right at 5, exactly.
A lot of times this will be written with a little union symbol in between the two. Looks like a U. Union means this and that all included together. A union of those two. Should have learned that in middle school somewhere. Okay, now we said range. Mr. Creswell said those are y values. So why don't we take a look at the graph of this one? Can you get us to the... We graphed y equals 2 over x. It took 2 math teachers a good 5 minutes to do that. But if we're looking for the range, those are the y values. So here's my y-axis. Let's say every value here has a spot that corresponds to it on the graph. Even down here, all these spots are also on the graph corresponding to the y-axis, except right along here, the graph never touches it. All right, that's called a horizontal asymptote. It gets really close to it, but it doesn't touch it. So this is not in the range, but all these other numbers are in the range. So I would say, if we're looking at the number line here, all the numbers are in the range except 0. And that's an open hole. So how would you write that, Mr. Creswell?
So I'd probably write, for the range, we're okay from negative infinity to 0, but not including 0. Or we can also be not including 0 to positive infinity. So anywhere in there except 0 is okay.
Very cool. So that's range or y values. Range or y.